Hello there once again. Welcome back to our Chem 152 video series. In this video, we'll be talking about the vapor pressure of solutions and how to use Raoult's law. In our question, we'll have a mixture of ethanol and methanol with 70 grams of ethanol and 30 grams of methanol. We are also given the vapor pressure of pure ethanol and the vapor pressure of pure methanol. And we're going to start by finding the mole fraction of both methanol and ethanol. This is necessary because in order to use Raoult's law, we'll need to first find the mole fractions. The question tells us first that we have 70 grams ethanol, 30 grams methanol. We'll need to convert these grams to moles for both of these substances. So we'll be getting out of grams and into moles for both. However, in order to do that, we'll need to compute the molar masses. We are given above that the formula for ethanol is C2H5OH. We'll write down how many carbons, hydrogens, and oxygens we have. There are 2 carbons, 6 hydrogens, and 1 oxygen. Go to your periodic table and look up the masses for carbon, hydrogen, and oxygen. On the table, you'll find carbon is 12.01, hydrogen is 1.01, and oxygen is 16.00. We multiply straight across and get 24.02 for carbon, 6.06 for hydrogen, and 16.00 for oxygen. Add together all the molar masses to get the total molar mass of ethanol. If you use a calculator, you'll get 46.08 grams per mole. This 46.08 will go next to grams, and we place a 1 next to moles. We now do the operation 70 divided by 46.08, and we'll get 1.52 moles. We repeat this process for methanol. We'll also count the carbons, hydrogens, and oxygens. There is 1 carbon in methanol, 4 hydrogens, and 1 oxygen. We already know the molar masses, so we'll write them again. We'll multiply straight across again and get 12.01, 4.04, and 16.00. Once again, add together all the masses to get the total molar mass. We'll get 32.05. Place that number next to grams for methanol. Place a 1 next to moles, and once again we divide. We'll get 0.936 moles for methanol. Now that we know the moles, let's remember what mole fraction is. We'll begin by finding the mole fraction of ethanol, abbreviated with an X. I'll write ETH to show that it's for ethanol. On the top, we will place our moles of ethanol. On the bottom, we'll place our moles of ethanol plus our moles of methanol. Our moles of ethanol were 1.52. Place that on the top and on the bottom. Then add on the bottom our moles of methanol, which are 0.936. It may help to place parentheses around both terms in the denominator, and then go to your calculator and divide those terms. When we divide, we get 0.619 for our mole fraction of ethanol. To get our mole fraction of methanol, we can take 1 minus our mole fraction of ethanol. Because there are only 2 components in the solution, we know that the total mole fraction for both must be 1. All we need to do is subtract out the ethanol to get the methanol. So we'll take 1 minus 0.619. We'll end up with 0.381 for our mole fraction of methanol. The reason why we had to get the mole fractions is because Part B asks us for the vapor pressure of methanol and ethanol in the vapor above the solution. We must remember that if we have a mixture of two liquids, both of them are going to try to turn into gases at least a little bit. So imagine that these yellow dots are ethanol. Since our mole fraction for ethanol is a little bit higher than methanol, that means more of this is going to be ethanol than methanol. So we'll put some amount of yellow dots and some amount of orange dots for methanol. Now, every liquid wants to become a gas at least a little bit. So above the solution, you'll have a little bit of ethanol, a little bit of methanol. We just don't know how much yet, and so Raoult's law is going to help us find what the pressure of the vapor is above this solution. Raoult's law says this: that pressure of that vapor is equal to the mole fraction multiplied by the standard vapor pressure. We'll abbreviate the standard vapor pressure as P0. We'll start by finding the vapor pressure of ethanol. Now, we already have the mole fraction of ethanol, that is 0.619, and we also have the vapor pressure of pure ethanol, that's 44 torr. We'll write mole fraction times standard pressure. Mole fraction was 0.619 multiplied by the standard pressure of 44 torr. We can multiply this in a calculator. We'll get 27.3 torr of ethanol. We can do the same for methanol. Once again, saying that pressure is equal to mole fraction times standard pressure. The mole fraction for methanol was 0.381. We got that previously as well. Then we multiply by the vapor pressure of methanol. For methanol, that's 94 torr. Go to a calculator and do the operation. We'll get 35.8 torr. So the pressures of both gases above the solution are now known. We know our pressure of ethanol and methanol. Part C may look a little confusing at first. This says to find the mole fraction of methanol and ethanol in the vapor above the solution. We found two mole fractions previously, but that's going to be correct for the liquid portion. The mole fraction of the vapor above the liquid will be different. However, the pressures we found previously will help us get that mole fraction. The mole fraction in the vapor is as follows. To find the mole fraction of ethanol, we'll say pressure of ethanol on top divided by the pressure of ethanol plus the pressure of methanol. So this time we will not be using the number of moles from the liquid part. We will now be using the pressures from the vapor part. Thankfully, we already have all the pressures we need. On the top, we will place our pressure of ethanol, which is 27.3 torr. On the bottom, we'll place our 27.3 torr and add the other pressure, which is 35.8. Again, remember to place parentheses around your denominator. Now we'll perform the operation in the calculator. When we divide, we'll get 0.433 for our mole fraction of ethanol. Once again, to get the mole fraction of methanol, we only need to take 1 minus the mole fraction of ethanol. We'll end up with 1 minus 0.433, and we'll do that subtraction in a calculator. We'll end up with 0.567. So now, not only do we know the mole fractions in the liquid, we also know the mole fractions in the vapor above that liquid. Thank you for watching. We'll see you again soon.